So you all have these graphs written down in your journal. I'm going to be labeling different points. So I want you to look, and we're going to talk about all of these critical points. So today when we talk about critical points and extrema, which is simply the plural of extrema, think of the word extreme. Okay? When you're talking about the word extreme, right here, you guys probably know that this is a maximum, known as a vertex of a graph. But in this particular case, it's not just the maximum, it's known as the absolute maximum. It's the absolute maximum because that's the highest that it gets. That's absolutely how high it gets. It does not get any higher than that point. Okay? So if this is the absolute maximum, what do you all think that this is going to be referred to as?
Maximum, low, and minimum.
Okay, so it's the lowest point, correct? But think about what do we call minimum wage? That's the absolute lowest you can get paid.
Lowest.
So we would refer to it as the absolute minimum. Now you're used to just saying it's the minimum, okay? But now we're going to be even more specific. Say this is the absolute minimum, okay? Now, a new vocabulary term today that you probably haven't seen before. I want you to see that this graph here has a couple of different ways it's curving. It looks like it's curving this way to a certain point, and then at a certain point, it starts changing. Okay? So the point at which one curve changes to another style of curve. All right? See how the curves are different here? The blue part is different than the purplish part. All right. At the point at which the curve changes, that is called a point of inflection. He's looking at his vocabulary and which one best matches it, okay? So, what I want you guys to do in your journal is not just write down the definitions of what they are, but put pictures with them, okay? A point of inflection. Can somebody read the definition of a point of inflection, Liz? Can you read that? What does it say in the book? Yeah, there's not, hold on, read the last sentence here, what does it say?
A point of inflection is a point where the graph changes its curvature as illustrated.
So, that makes sense if you have a picture to kind of go with it. So, at the change in the curve, that's what's referred to as a point of inflection. So go and get those down, alright? We've defined, what do you mean we've defined? We've actually defined 3 of our vocabulary terms. Absolute maximum, absolute minimum, point of inflection without having to write definitions. Alright, you've got to be able to identify where those are. Alright, hopefully you have this graph in your journal. I'm going to label 3 points, and I want you to label them with me. Okay? One of the critical points I'm going to put right here. That's one critical point. Another critical point I want you to put right down here. And the third critical point I want you to put basically right in here. We'll talk about that one last. Okay? Alright? By the way, yes, I'll let you try to name them. That's fine. Notice, before we name them, technically, where does this graph go down to technically? Negative infinity. That's what's referred to as its end behavior. And this one up here, where it goes to positive infinity. Now listen, when your graph goes to a negative infinity and a positive infinity on either side, technically you cannot have an absolute minimum, nor can you have an absolute maximum. Alright, because there's no maximum when it's going to infinity, and there's no minimum when it's going to negative infinity. So now we're going to change this. This is not considered to be an absolute maximum. You know it, right?
I know it.
Yes, I got it.
Okay.
All 3.
Hey, how about this? You let him know if he's right. Alright. What do you think it is?
Relative.
No. Just one at a time.
Relative maximum.
Yes, right here. What I'd like you to label this. Oh, I forgot.
Yeah,
Sorry,
he's
Liz.
right.
He's right. I apologize. Should have let you tell me. This is a relative maximum.
I got it.
No, don't tell me this. Don't tell me. All right, we get somebody else. At least you wanted to go, right?
Yeah.
Okay, so hold on. Make sure you get the correct point. I'm going blue, not green. I'm going blue.
Wait, are these the ones that I went over?
No, this is new.
I'm just kidding. I thought
Okay, Liz, you want to tackle this one? What do you think this one is?
Relative minimum.
This is the relative minimum.
Ooh, I get that.
Oh, point of inflection.
No,
Yeah.
it's the relative extrema.
Nope. This is still the point of inflection.
Really?
Yes.
Oh.
Oh, man. Now, Ryan, could you tell me what word that you wanted to use? What set of words? What did you just say?
Relative
Extrema. Okay, now listen. That is basically talking about the absolute. That's right. The relative minimum and the relative maximum. Those are referred to. Okay. So when you said this, I'm going to tell you what you just said. When you said the relative extrema. All right. When you say that, it's referring to both the relative max and the relative minimum. This right here, by the way, I said this is the plural of. Okay, so we'll go back. Right here. This is the plural of. This is singular. All right. This is plural.
So if you just want to talk about the relative maximum, you'll say the relative extrema.
The relative extrema is the relative maximum or the relative minimum. Now, next thing I want you guys to do. All right, I want you guys to shade something, if you can, please. I want you to shade this curve in one color, and I want you to shade this curve in another color.
You got some colors that you use?
I do. We pause. Do you guys see how this is curving down? This is referred to as concave down. This part of the graph is referred to as concave down. Now, obviously, I'm kind of looking at my relative maximum. I guess I could have shifted it over just a little bit to make it see better, but we'll just leave it the way it is. All right? So this is concave down. What do you think this is referred to as? Concave up. That's right. Concave up. Now, concave down and concave up. If you're thinking about it, Myra, could you please stop talking? Thank you. If you're thinking about it, where the graph turns from concave down and starts turning to concave up, that's where we get this idea of the point of inflection. It's the changing of the curves. All right? So when you're looking, that's what I want you guys. When you're looking at a graph, and I have you label something on a quiz or a test of where's the point of inflection, look at where the curves start to change. Okay? So that's why I wanted to highlight it, because this is the point of where it starts going from what, concave down, and it starts turning to concave up. That's what you want to look for. All right? Now, on your paper, what I'd like you to do, all right? On your paper, I want you to start looking at problem number 1. All right? So let's look at problem number 1. All right? And we're going to start labeling some things. So let's start with some easy things from problem number 1. We're gonna label this point right here. Okay, we're gonna label this point right here, and we're gonna label this point. I'll probably change colors here. Put this one red. This one green. So we're gonna start with the blue, the red, and the green. Okay. So let's go with the ordered pair for the blue. Looks like we go over -1, -2, -3, -4, -6. 1, 2, 3, 4, 5. So it looks like we're at a -6, -6. So at this point, what do you think we're going to call this point right here? What would be the best description? Go ahead, Ryan.
The absolute minimum.
This is the absolute minimum. You're correct. That is what's known as the absolute minimum. So on your paper, I want you to label absolute minimum. That's what I'm looking for. Absolute minimum, and I want the ordered pair to go with it. Okay? All right, so now I want you guys to look at this -2, +1 right here. Now, Ryan, I already let you go. Does anybody else want to take a guess at what that is?
Absolute max.
It's the relative maximum. Now, this is referred to as a relative maximum. Let's think about why it's the relative Notice, this is the lowest point. It does not go any further down. So that is the absolute minimum. However, up here, does this graph ever get higher than that particular point? Right here. It does, because this goes to what? Positive infinity, and over here, this goes to so technically, it technically has no absolute. No. It has no absolute maximum because it's going forever to positive infinity. All right.
I was thinking there's no negative infinity.
So with that, X will be a relative.
Yeah.
Very good. Jordan, I heard you, and Liz, I heard you. Yes, this next one is not the absolute minimum, it's the relative minimum.
So I don't understand the difference between relative and absolute.
I'll try to explain it, okay? All right, so here we go. Relative minimum, it looks like it's at a 1, comma, -2. So I want you to, I'm going to change over here, just follow the hand here, Liz, all right? So check this out. Here, this technically is the lowest point. The graph does not get lower than that. So that's why it's called the absolute. But the graph increases, right? It increases, and then it starts to what? Decrease, but then it bottoms out again, and then increases. So since it bottoms out again, that's referred to as a relative minimum in the graph. It's not the absolute minimum, it's a relative. Now listen, let me tell you one thing. If I were to change this graph, and make it go down, right here, don't do this on your paper, but if I were to make this graph turn down, okay, then that would change what this is. If this graph turned down, then this would no longer be the absolute minimum. That would change this to a relative minimum, because now I'm changing the graph and making it go down to negative infinity, okay? But because the end behavior ends here, and the other end behavior ends over here, that means we have an absolute minimum. Okay? Now, Liz, if I turn this down, and I turn this down, then this changes from a relative maximum to a what? Well, actually not there. Hold on, I gotta change where it goes. My bad. If I change it here, make it go down here, like I turn the graph, and then I turn the graph, then it would be the absolute maximum. Otherwise, the other one would be absolute. All right. Now, I'm not going to make you label these on this particular one, okay, because it's kind of difficult to find where they are. But I'm going to do some curves here, all right? This one right here is curving down, right? I'd say to right about here, and then it starts, right, it curves up, then it starts your curving down, and then again, it starts to curve up, all right? Now, I'm not going to make you guys label these on your graph because it's kind of hard to find exactly where they are. But what would you call these points right there where you see it start to turn? Yeah, those right here are points of inflection. And since they don't really have an exact ordered pair, I'm not going to make you label those. Okay? So the answers I want for this one is simply absolute minimum, relative maximum, and relative minimum. Okay? What you're doing on problems 1 through 4 is you're labeling, all right, your relative extrema. All right, you're labeling those. All right. So what I'm going to do right now is I'm going to put points of the ones that you need to label. Oh. So we zoom out. Okay. I'm going to tell you the points that you actually need to label. We've already done number 1. All right. On number 2, the point I want you to basically talk about is this point. Number 3, talk about this point. Number 4, you're talking about this point, and I am making you label this point right here. So you're going to be labeling those with an ordered pair and using the vocabulary terms to describe what those